Okay, for this question, you kind of do need to have a pretty good sense of geometry. Remember, the formulas are mostly provided for you at the beginning of the section, but you really need to know things that are beyond that list of formulas. This is a good example of how when you practice a lot, you're going to start to notice different patterns that make the questions similar, even when they look really, really different. So what I notice immediately on this question is that it's composed of two triangles. And my get back to basics brain knows that when there's two triangles in a picture on the SAT, the odds are pretty good that those are similar triangles, meaning that their sides are in proportion. I can set up ratios to compare things. So I know that I want CE, which is the full length of this side. So CE is my goal. I'm going to want to compare CE to the similar piece in another triangle. Well, there's the big triangle that CE is made up of. And then there's this little triangle here that has CD as its long diagonal side. So I can compare CE to CD. We could flip them around too if we want. It doesn't matter. As long as we're consistent with our ratio, we're going to be able to put those two things together. Now I'd love to also have a ratio that compares the big triangle, big to small. So the only other side of the big triangle I have is EA, which is 18. And I would want to compare that to a corresponding side for the little triangle, which it looks like is DB. Those two things seem to go together. So that's just kind of common sense here. So the problem with this setup is I have two variables. I don't know CE, which is what I want, but I also don't know CD, and it seems like I'm going to need to get CD in order to be able to answer this question. Now, this is a good example of how showing your work can actually tell you what to do, because now I have a goal. I need to find CD in order to be able to solve this. So I look at my triangle and I'm like, okay, what can I do? Well, this is a right triangle as well. And whenever I have a right triangle, I can use Pythagorean theorem, a squared plus b squared equals c squared. So if I have two sides of a right triangle, I can use Pythagorean theorem to find the third side, no matter which two sides I have, no matter which side I'm looking for. In this case, it's very basic what we need to do. We have the two legs of the triangle, so 6 squared plus 8 squared, and that equals the hypotenuse squared. So I'm just going to put CD in there so I remember what I'm actually looking for. And that's going to be 36 plus 64 is equal to CD squared. 36 plus 64 is 100 equals CD squared. And then we take the square root of both sides to get that CD is 10. And you may have known that just by looking at this, because there's a very common thing that they do on the SAT. There's a special set of right triangles that follow the proportion 3, 4, 5. And it's a proportion, so we could multiply each of those by the same number, and we know that that would still be a valid right triangle. So 6, 8, 10 is one of them. 9, 12, 15 is one of them. And there's yet another that we can keep going up, but let's use the proportion this time. Let's get rid of our CD, plug our 10 in there. And now we can cross multiply and divide. So I would do 6 times CE, 6 CE, and then 18 times 10 is 180. Divide by 6, and we get that CE is equal to 30. And that is my answer. And so we could have, we could keep going here and try to figure out using the proportions what we're dealing with, but the 3, 4, 5 proportion what we're dealing with. But it's so much easier to just kind of plug it into this original formula we had and just let the math show us the answer here instead of kind of playing guess and check. But as you do other practice tests, pay attention when they give you these kind of like triangle pictures. Even though the pictures will look very, very different, a lot of times you're actually going to be solving them this exact same way, using ratios to compare similar triangles, and maybe Pythagorean theorem to find a missing side as you go. But the SAT is not that clever with geometry. They're very consistent. So the more practice you do, the more you'll recognize those patterns, and next time it'll be so much easier to solve.